So I think more than anything, what I was really struggling with was, I guess, understanding where to use the different methods that we're taught to use.
Are you talking about the partial fractions?
Um, I don't know really how to put it. There's four questions that I don't have an answer for yet. But
Right. That was the
the chapter,
7-4, right? 7-4 was the partial fractions, right?
yeah,
Yeah. Okay.
that's where three of the questions are.
Right. Okay.
So let's just start with 7-4 then. Hmm. Sorry, I'm just trying to look over them. Yeah, it's typically with like two and on, especially in problem two, is how do I put this? I felt like I was kind of brute forcing it. You
Do you mean plugging in values for x?
Yeah, pretty much.
Well, I mean that's okay, especially for the earlier ones. But then for the later ones, as you get to more complicated forms in the denominator, then you're inclined to do more of the algebraic approach.
hmm
Mm.
Um. Hmm. Okay. So the two that I haven't done, uh, or that I haven't gotten answers for yet, are B and F.
B and F on two,
Yes,
right? And B,
and then
I've discussed with students, and now part of that is factoring. Were you able to factor that?
B.
This four term guy.
I don't think so. I also sorry. H is another one.
Okay. Well, which one would you like to try first?
Let's try B.
B. Okay. So first of all, let's do the factoring quickly. And the idea was to remember things like the rational zero test. So you consider factors of the -10 over factors of one. Basically, you're going to get. Uh, so basically, you're going to consider at first for rational zeros plus minus one, plus minus two, plus minus five, plus minus 10. Okay. Again, the factors of the -10 over the factors of one. That's the rational zero test, right?
Mm,
Uh, okay. Do you remember that? Do you remember that from chapter two, like 2.5?
I vaguely. All right.
Right. Remember over plus minus one? Remember that jazz? Right. Factors of the -10 over factors of one, right? And these
Okay.
are the possible rational zeros. And the plus, since we're divided by plus minus one, I can just delete this stuff. And I don't think a number like a number as extreme as 10 or -10 is going to work out. Let's see, one, just by looking at it, I don't think one's going to work out. -1, I think, might work out. Let me try that. -1, I think. Take the coefficients 1, 4, -7, -10. They're descending powers, no missing terms. Remember the process. One comes down. Multiply, add, multiply, add. This is looking good. Multiply, add. Does that process look familiar? And we're happy with the zero here?
Yeah.
Right. Okay. Now, I'm again the goal. So this is part of the problem, right? It really is a substantial part of the problem. The goal is to factor that denominator over the reals, right? In fact, I think we can do it over the integers. Now, it looks like -1 is a zero, and because -1 is a zero, you know it's a factor. X not -1, but +1.
Okay.
Remember that? Okay. If k is a zero, then x minus k is a factor, right? -1 is a zero of this polynomial in x. Therefore, x minus -1 or x plus 1 is a factor, right?
Okay.
Okay. And do you remember where we get the coefficients for this quadratic guy? A third degree guy divided by a first degree guy is a
Mhm.
second degree guy. Where do we get the coefficients? We get them right here, row
Yeah.
3. 1x squared plus 3x minus 10. Okay. And then you can either use the quadratic formula, or it turns out this does factor old school. It's going to be a split in signs because it's a negative. Looks like a +5 and a -2. Okay, so I'll write this as star. So star, that guy I'm giving you, right, is equal to okay, well the numerator, right, over. You factor the denominator, it's get x plus 1, x plus 5. I should have got a new page, but x plus 5
Okay.
times the x minus 2. Again, I should have got a new page, but yeah. So that's a
And then we
quarter.
continue it like we would the other problems,
Right,
correct?
right. And even though there are three factors down here, the fact that they're all distinct and linear, they're all different and linear, the plug-in method works. So you're going to tend to plug in x equals -1 when you get the basic equation, right? X equals -5 and x equals +2.
Hmm.
Right, let me make sure that that's factorization. Um, it's okay to peek just to make sure you're not on a wild goose chase.
Hmm.
Let's see here. Yeah, that's right. That's going to be the factorization. Okay, so the form is a over any order, A over one guy plus B over another guy plus C over another guy.
Okay.
Right. Oh, and by the way, for timing's sake, at 6:15, I have another student coming in, so I'm just kind of watching the clock, just kind of pacing
Of
ourselves.
course.
Right.
So then F and H were the other two that I just wasn't really getting.
Okay, so let's take a look at F. Oh, and here, this is factoring by grouping. So if you know factoring by grouping, it's not so bad. The question is, do you remember factoring by grouping? It's
I
off.
don't think so.
Yeah, it's in the closets of a lot of people's minds when they came into the class. Um, okay, I just reviewed it briefly. Okay, so let's get a new uh, whiteboard for this one. All right. Okay, so again, let's begin with factoring that bottom. Let's get back right to the point. So the denominator. Oh, by the way, this is a okay. I want to let's see. Over here, this was B, right? Okay, so this was a 7.4 to B, by the way. All right, and then this one here is 7.4 to F. Okay, so the denominator, okay, factoring by grouping. So I'm going to group x cubed minus 5x squared plus 3x minus 15. All right. Okay. It's just kind of
Okay.
naturally group the first two terms, group the last two terms. What's the GCF from the first group? The
X
first
squared.
x squared, right? Other factor is x minus 5, right? Plus, what's the GCF here? Is this a number?
3.
3. And we have, hey, look at this, x minus 5. That bodes very well for factoring by grouping because there is a common binomial factor. We can now factor that out from the whole expression. Either side, let's see on the right. And what are the missing pieces here?
X squared and 3.
Correct. X squared plus 3, and that's prime over the reals. So
Okay.
this is the complete factorization of the denominator over the reals. And again, that's a quarter of the battle, right?
Okay. I vaguely remember this.
Right. So quickly, if you do, okay, oops. So when you do numerator over, okay, I'm going to write down this factored form here. I'm going to put the linear guy first, just to make a point. Linear guy, and then the prime quadratic. Now, because of the x minus 5, we're going to need as a partial fraction a or whatever letter over x minus 5.
Hmm.
Right?
And then mx plus b form for the other one, correct?
Very good. So, for example, bx plus c. Right.
Bx plus c, yeah.
Very good that you remember that. Right. A lot of people forget that over x squared plus 3. I mean, it may
Okay.
turn out that b is 0, but you don't know that yet. Right.
All right, cool. I think that's just what I was struggling on because I kind of get the what methods we're using here to solve these problems. I'm just having a hard time figuring out the little tricks like factoring by grouping. All right,
Right.
I think I
Uh,
got this.
okay. So quickly, here's a basic equation. Numerator equals a times who's missing x squared plus 3 in parentheses
Hmm.
plus bx plus c, x minus 5. What do I need? What do I need?
You need parentheses around that so
Yeah,
that you're not just multiplying by the c.
that's right. Because that's a very, very common error.
Yes.
Right. Okay. Now in terms of strategy, what's a great value of x to plug in?
5.
5, right? And then some people might choose a couple more values. Personally, once I plug in x equals 5 and figure out a, I'd plug that value in, and then I might go to the algebra method where I use a matching coefficients method where I distribute,
Mhm.
see what happens, and actually do more with my algebra. Because 5 is the only value for x that's super great.
Okay, so I have a question.
Huh?
I think it might have been an earlier question. I want to say 2C, where I could have used the I kind of brute forced it by keep plugging in values.
That's always legal, right?
Okay, cool.
Although you should be warned that, like on the harder problems, like this one, for example, where you
Yeah,
have
no, that's not going to be practical.
quadratics, yeah, then you're in danger of having a system that you may need to attack using matrices, perhaps.
Mhm.
So that's a little dangerous. um, if you're lucky, it might be a sparse system. But generally speaking, as you work down this list, as the denominator gets more and more complicated in terms of the type, then you tend to move away from the plug-in method and more towards the algebra method. Although in principle, either method works. It's just that sometimes if you do it with the less efficient method, you're in danger of solving a more complicated system.
Okay.
With B's and C's and all that stuff.
All right. Um, can we go over H real quick?
Sure. All right. So F.
Sorry. Also, could you pull up the first one again? B.
Oh, the solution I had, or
Yeah.
yeah,
I just
right.
need to take a screenshot real
Screenshot.
quick so I can reference this to make sure I'm doing it right later.
Right. The key point being the factorization, right?
Yeah, yeah. That's synthetic division, correct?
Right.
Yeah.
Both the rational zero test and synthetic division.
Yeah, yeah.
Right.
All right.
It was nice. It was a nice spiraling problem.
All right, cool. Yeah,
H.
I think that's all I needed for B and F was figuring out how to start them.
The factoring. Sure, sure. And that was meant to be review. Good. Which a lot of people needed.
Yes, definitely.
That's what spiraling is, trying to go back and pick up previous pieces just to check that people haven't forgotten them. All right, H. Let's take a look at H. All right. Okay, let's go ahead and use red, unless it's triggering. Let's see, red. H. Right. We just talked about that one. Right. Okay. So like I said, okay. So this is 1.4 to H. Okay, so a lot of people get confused by the form, but I think you know what to do. You seem to be good at this. So numerator over t squared plus 4,
Mhm.
all squared, all right? Two partial fractions,
Work up to the power, right?
right? So t squared plus 4 here, and then the square here, or vice versa. The order doesn't matter, but you
Mhm.
basically have to have each power in there. And what goes on top?
Uh, AX plus B and CX plus D.
Very good, very close. T, A, T
Oh,
plus.
AT, yeah.
Yeah. Just to keep you on your toes, right? The physics people say that we need to use T more. So, all right. And then CT plus D. Because,
Yeah, so I think this is where I kind of got confused was the answer on the answer sheet had seemed to have it in a single value form
let
for
me see
C
here.
plus D.
I think C, what was it? C turns out to be 0, which is okay.
Okay,
It
that
is,
makes sense.
yeah, it is possible. Yes, there's nothing stopping C from being 0. So it appears that A will be 5, B will be -1, C will be 0, and D will be -4. I don't know if you attempted this problem, but
I believe I did a little, and I got really confused by that. I was questioning whether I did something wrong from the get go.
yeah, you're kind of scared as you proceed. Let's go over the basic equation. And I think your algebra is good, but let's start off the basic equation. So let's multiply both sides by the denominator here, LCD.
Mhm.
Get the numerator, equals. All right, and you know the trick. Parentheses, right? At plus b. You know those grouping symbols will save you. The quantity at plus b. We're missing a t squared plus 4 because when we multiply each of these fractions by this guy. Okay, one guy kills him, a second guy survives.
Yeah.
Again, in parens t squared plus 4. Okay, so a lot of people mess that up, but if you're careful, it's not so bad. Plus, we're multiplying this fraction by its denominator. Okay, now I like to start with writing parentheses ct plus d. Although bear in mind here, because that's a plus sign, these parentheses aren't so necessary, because there's
Mhm.
nothing else that we're doing. So these parentheses are optional. Still, I think it's a nice habit.
Mhm.
All right. So that's the basic equation, right? And you can see here that there's no real value for t that's immediately obvious, right?
Mhm.
So this is a situation where you may as well just go ahead and distribute like crazy, right? To foil this over here, combine like terms, and then go from there. Now,
Okay.
do you remember that procedure where we distributed, we combine like terms? So we basically get like, um, I guess we get a cubic here, right? Where we get a coefficient times t cubed.
Yeah.
Yeah.
Okay, so the setup for what is it? Matching coefficients.
Right. Okay. The idea being that, and then you do the same. So I know I had that squiggle there, but be careful here. So I might recommend on the left side, near the end, you might want to write something like at the end here, right? Like, okay, in parentheses, 5 times t cubed. I like to match up the pieces in parentheses. Plus, okay, what's the coefficient here? The coefficient on t
-1.
is -1. I think this is a good idea. If you put plus -1
Yeah.
times t squared, and then we can just kind of grab these guys in parentheses. Okay.
Mhm.
Whereas, remember, as human beings, we have a hard time processing minus signs in our head. So it's just really nice to have plus situations, and you just kind of grab these guys in parentheses, right?
All right.
Right. And then you match like the 5 to whatever this thing is, match the -1 to what this thing is. You equate them, right? And
Mhm.
you should get a pretty workable system, a pretty sparse system of 4 linear equations in 4 unknowns. Whereas, if you had done what you kind of implied earlier, if you had plugged in 4 different values for t, even fairly nice ones, your system might have been more heinous. It probably would have been a
Mhm.
bit more heinous. Yeah. Whereas here, with this method, you're more likely to get a sparse system that you can solve pretty easily.
Okay. All right. I think I just wasn't super comfortable with the matching coefficients method, but I think I get it enough now.
Right. If you work the algebra here, right, and you're careful, remember you set this guy in parentheses to the 5, this guy in parentheses to the
Yeah.
-1, right? That's why that trick works. I'm confident that you know the algebra. It's just a matter of being careful with your form, not dropping anything, right?
Okay.
Making sure that you're careful. But we had a very good discussion, and in fact, in our travels through number 2, I think we've done a good review of the various techniques, not just of reviewing factoring from chapter 2, but also just a kind of flavor of both method 1 and method 2, even though we didn't plug in anything yet, right? But
Yeah.
I think you know what to do, right? You know how to plug in values, just be careful, right?
Yeah. And that's really why I came here to talk to you, was because I was having trouble understanding when to use the different methods and not so much with the actual math itself.
Oh, right, right. Yeah, and as I mentioned, if you have something like even something like B, where you had different linear factors, right? Where you had like these guys here, x plus 5, x plus 1, x minus 2, and there are no powers, right? Even
Mhm.
though there are 3 of these guys, it's an easy process because the plug-in method works in very well. Every time you plug in a nice value for x, you have some value for a, b, or c or whatever coming through nicely, right? And you go through one by one. Whereas as you go more and more towards these prime quadratic type things, then you tend to move. Well, I mean, you plug in. Usually, people like to plug in whatever they can if it
Mhm.
makes something nice. But then once they get kind of stuck, if they see the tunnel, if they see the light at the end of the tunnel, they might just plug in 1 or 2 more values. But other people might go, you know what? Let's go straight to the algebra. Let's plug in the values we got. Let's rewrite the basic equation and let's work the algebra. And it might depend on your own personal comfort with your basic algebra. I mean, what you're feeling towards your basic algebra. It might depend. Some students often make mistakes with their basic algebra, and they might prefer just plugging in. Other people feel very comfortable with their basic algebra, and they're like me, and they can't do arithmetic at a whiteboard in real life. So
All right. The last question that I had, and this should be fairly short, was on 7.1 actually.
right.
And that would be 3C. was I was
Okay.
having a little trouble.
Yes, yes, and I see that I discussed this briefly with another student, perhaps. So, oh, okay, so, oh yeah, yeah, yeah. So, first of all, what are the graphs of these things? Just kind of sketch this out. And you don't have to be too artistic, but x squared plus y squared equals 3/2. Do you remember what that graph says? X squared plus y squared
That's a
equals,
circle.
correct. A circle starting at the origin, right? And then now, if you divide both sides by root 2, you get y equals x squared over root 2. That's a nice step anyway, right? Basically, x
Okay,
equals a positive number times x squared. What's the shape of that graph?
sorry, give me a second.
Well, for example, how would you graph y equals x squared or y equals 2x squared, 3x squared, or even 1 over root 2 times
Uh,
x?
sorry. I was just erasing some of my work. That'd
Yeah,
be a parabola, correct?
correct. Parabola opening upward. And how many intersection points do you think we're going to have here
Mm,
between the
two,
circle and the upward opening parabola? That answer is
two.
B. 2, correct. And yeah, you have to be a horrible artist not to see that. That it's going to be 2, right? So even though I'm a horrible artist, even I could probably figure out that's going to be 2 intersection points, which means you're going to get 2 real solutions. That is 2 ordered pairs. Okay. And bear in mind that in principle, we're supposed to check our solutions to a nonlinear system, but because we can get y as a function of x, and because we have a graphical sense as to how many solutions we're supposed to get, checking isn't as essential. And to
Okay.
be blunt, many books are sloppy with that idea anyway. Um,
And sorry, we prefer y as a function to x over just plugging in y root 2 into where x squared is, correct?
well, the thing is, it's convenient for the purposes of substitution, right? This expression for y, I can now plug in. I think that was the nicest method, where you took this expression for y and you plugged it in.
Yes, but I'm saying it would be more practical to do it that way than just plugging in as is originally, as a as
Oh,
opposed to
you
plugging
mean
in.
replacing the x squared with y root 2? That might
Yeah.
be awkward. That might be awkward.
Yeah.
Yeah. Not
Okay.
that that's wrong, and students have done that, and it's a matter of which path do you take through the forest, right? You may not know yet. We're not all clairvoyant, we don't
Yeah.
we don't know what's going to happen. So even you could be the best math student in the world, and you happen to take the wrong path, and you have to be resilient enough to say, hey, I'm going down the wrong path, so I got to
Got
backtrack.
to go back and do it right.
Yeah, and if anything, I want you to learn that. I mean, it doesn't matter how smart you are. You're going to run into these cases where, hey, you see the left fork, you see the right fork, pick a fork. You might be wrong. Okay, well, be resilient. Come back and try the other fork.
Yeah.
Yeah, that's life. Yeah, that's math life.
All right. Cool. I did that and I looked at it and I was like, I don't know where to go from here, and I just didn't think about putting it in terms of why. All right, that makes more sense.
Right, and there might be other problems where you can solve for x. I mean, in principle, there's no reason to prefer solving for x or solving for y. It depends on what you see, right?
Hmm.
Yeah.
All right, I think that answers just about all the questions that I needed help on in section or in chapter 7.
Okay.
Uh,
I can give you a few moments to look things over.
um, can you pull up H again?
Right from the partial fractions. Right. Oh
Or
yeah.
I mean the whiteboard for it. Thank
The
you.
whiteboard. Yeah, my whiteboard. Yeah, yeah. And that means that you're going to solve a system, hopefully a sparse one,
Yeah.
with A, B, C, and D. Yeah.
All right. I haven't really found anything I'm struggling on chapter 8 yet, though. Of course, I'm not too far into it.
Right.
Um,
And some people remember it from their math, 96 class or whatever, intermediate algebra. It depends on your background. Yeah.
hmm. Hmm. Yeah, this is I think my second math class out of high school. So aside from reviewing trig, I haven't had much college class math.
Mhm. That's okay. I mean, there are thousands of students in your boat. Yeah, it's a matter of
Yeah.
making sure that all the boats are rising, right?
Hmm.
No,
All
it
right.
sounds like you're doing fine.
I mean, if there's anything that I genuinely don't feel, or if I genuinely feel like I don't know what I'm doing on, I typically find that either some of the other students or you can help me fairly quickly. So I don't feel like I'm particularly struggling.
Oh, you seem like you're doing fine.
Yeah, yeah. Um, yeah, no, I think that really answers just about everything I was not sure about.
Okay,
Thanks again
well,
for all the help.
you're very welcome, and I'll be checking my. I'm not going anywhere, so I'll be checking my
Yeah.
email every day, even Thanksgiving. So yeah, I'll be checking my email. I'll be around, and good luck. And I think you'll be fine here. But if you have any questions, let me know.
Okay. Thank you. Take care.
You're welcome. Have a happy Thanksgiving, and maybe we'll keep in touch throughout the week.
You too.
All right, thank you. Take care. Bye bye.